Good morning, everyone. This is Asiyah. Today, I'm going to talk about how we plan to use ontology to build the minimum information standard about viral control, MIAViC. In today's talk, we will feature 4 activities that are related with diagnostic testing for coronavirus. As we all know that the diagnostic testing for COVID-19 is a key element for us to be successful in fighting coronavirus. First, Marc Salit from Stanford will show us his work on coronavirus standard working group, and then James Phillips will show his visualization on EUA diagnostic testing data. And then Aaron from veritasdx.com shows us his public available COVID-19 testing controls databases. And during the keynote speaker after this talk, given by Dr. Sampath, he will talk about federal level SHIELD project for livid test code mapping efforts. Finally, I will briefly introduce the EUA diagnostic testing modeling that's done by me earlier this year as a part of CIDO coronavirus infectious disease ontology. Now let's start with Marc.
Hi, I'm Marc Salit. I'm the director of the Joint Initiative for Metrology and Biology, or JIMBI, as we call it, at the Stanford University and SLAC National Accelerator Laboratory. We do standards, controls, measurement science, tool development to support confidence in biological measurements. We try and do innovation along those lines and are a nice outgrowth of programs that were at the National Institute of Standards and Technology and build on the experience of consortia like the External RNA Controls Consortium and the Genome Metabolic Consortium. In March of 2020, we formed a new consortium, the Coronavirus Standards Working Group, to develop the infrastructure that's going to be needed to have a testing enterprise that we can rely upon. This working group has representatives from government agencies, professional societies, the commercial sector, and that includes commercial technical labs, technology innovators, clinical laboratories, producers of controls and reference materials, as well as academic labs that are either clinical laboratories or academic innovators, developing new methods to test for molecular species and evidence of biological response to those. This working group has a portfolio of projects that are focused most recently on developing a list of what standards are available and how to deploy them accurately, or how they can be used accurately, as well as some interlab studies that will establish the comparability of those materials and establish their utility and traceability to the international standard, which should be rolling out in a matter of months from the World Health Organization and its labs that are the labs it works with primarily at the National Institute of Biological Standards and Controls in the UK. So one of the things we've been trying to do is get a handle on what standards are available. And in doing so, we've categorized them. This is a workflow or a process model diagram for molecular testing, usually PCR, but sometimes isothermal amplification, that looks for genomic evidence of the virus. There are a number of different roles for controls in this workflow, in this process. There's a number of different process elements, and you can establish the performance of the process elements individually or across the whole workflow or from start to finish using viral surrogates and viral controls. The key thing to note here is that we've got to be able to accurately tell you what this control is and how to use it well. in order to assure enterprise quality through appropriate use of controls and standards. Back in May of 2020, our working group compiled a list of about 50 different available control materials and discovered that there was no uniform way to describe these controls and no uniform way to know which controls would be appropriate for use in a systematic way throughout that measurement process. Ultimately, from this experience, we've committed to developing a minimum information standard about a viral control, or what we're calling MIAViC, that captures the key attributes of that control material. And the categories we've identified so far for MIAViC elements, or MIAViC table elements, are the utility, the target description, the surrogate type, supply chain handling, what's probably the most important piece, the analytical characteristics and attributes, and finally housekeeping attributes, so we can keep track to make sure that interoperability is maintained.
Hi everyone, my name is Alexander James Phillips. I'm a research associate at the Center of Complex Interventions based in Boston, Massachusetts. In April, we published an interactive tool to help laboratory managers and clinicians make sense of the raft of new diagnostics being given emergency use authorizations. This is a screenshot of one of the visualizations showing the main steps involved in getting from a patient being tested to a test result. Below each category are some of the different values for each step. This is made possible because we manually parse the documents and normalize them into these categories. We've been working on updating and extending this data with additional fields. We produced an initial ontology, part of which is shown here. This is JSON code of a list of labels. The labels are nested, and that nesting represents a simplified version of the relationships between each part. For example, all tests are evaluated using some kind of viral material, and the viral material has many high-level subtypes such as live virus, naked RNA, or synthetic viral particles. We use these labels to manually annotate the EUA PDFs. For example, quantified clinical sample is labeled here as live virus. Subsequently, we can pull out this information into the kind of visualizations on the previous slide, or for example, this table on the right. This table shows some of the range of values that map back to the same high-level concept, similar to the variability descriptions of the viral control material Marc talked about earlier. At the Center of Complex Interventions, we've been very grateful to receive help from Asiyah in using ontological methods to better structure these labels. And at the bottom of the slide, you can find a link to the project and its raw data. We welcome anyone who would like to contribute either to the ontology or to the structuring of the diagnostics data. Thank you.
VeritasDX is a free and unbiased resource to help scientists, health officials, and others search for SARS-CoV-2 tests using criteria they choose for themselves. By analyzing technical documentation, our volunteer group gathers data on assay requirements and detailed performance characteristics. This information is compiled into a searchable database, enabling comparison of methods according to user-defined parameters. Within seconds, we can filter, as shown here for example, for PCR test kits that have a positive predictive value above 98%. We can also assist in finding controls and standards, or the regulatory status of a serology test without an EUA. We're now developing a dashboard with analytical capabilities to allow users to ask specific diagnostics questions and find answers easily. Input from regulators and other data providers to reflect real-time practice will provide additional utility. Please reach out to the information below if you are interested in partnering with us to improve the availability and searchability of test method data. Thank you.
So now let's show you some ontological conceptual modeling that we have done for control material. The control material, first of all, is a product. Product has catalog number, and this kind of product is a biosafety level product. The product is manufactured by manufacturer, is distributed by distributor. The transport material is also a product. The control material has many subtypes, such as positive control, negative control, wrong control, false positive control, etc. James identified a list of entities, and controlled material are made of those entities. The ontological relations between those entities and control material needs to be defined. That is the future work. So here is a busy slide. I just want to show you the previous work that we have done for PCR testing in idle blue as well as in CIDO. In CIDO, we added the EUA authorization for the PCR diagnostic testing. So now, when it comes to control material used in the diagnostic testing, it is much easier. The red box here are the new terms that is identified by Marc's work. The control material is a RNA material for RT-PCR. All the other terms are already defined. We just need to add those new processes, materials into the current framework. This figure follows the ontology as glue to put things together and enable the interoperability of different systems and data. Ontology as an artifact that is behind the scenes of many applications, knowledge base, knowledge graphs, and databases. Ontology also supports the NLP tools to standardize the extracted information from documents. In our case, we will build the minimal information standard out from the ontology so that the data integration will be much easier. When different systems utilize the controlled vocabulary from a formally defined ontology, the mappings will be minimum and the data interoperability level will be much higher. For the future directions, we have following plan. First, we will continue the ontology work by forming a task force. We will represent all the 4 scenarios presented today. Second, develop the minimum information standard based on this ontology. The third, implement the standard to more other data sources and eventually achieve the diagnostic testing data interoperability, harmonization, and integration. We welcome you to join us. Please contact the email below for collaborations. Thank you.